If the resistance of a circuit increases, electric current decreases. We got this. If resistance of the circuit increases, electric current decreases. For example, in here, resistance is 5. Potential difference is 20. Electric current is 20 over 5, which is V over R. 20 over 5, which is 4 ampere. But in the second one, electric current is 20 over 10, which is 2 ampere. As you see, but resistance doubles, but electric current halves. As resistance increases, electric current decreases. You should replace the one resistor with another one to change the electric current. But this is not very practical. Instead of changing one resistor with another one, there is a device which is called Rheostat is used. Yes, this is also another important device. We will talk about chapter 6, section 1, Rheostat. Rheostat is a device which is used to change the electric current of a circuit. Rheostats are in fact variable resistors. They are variable resistors, rheostats. So it is possible to change the resistance of a circuit without replacing with another resistor. By using a variable resistor called rheostat, it is possible to change the resistance of a circuit. Like what? Rheostat is made of loops of wires wound over a cylinder. This is the diagram of a rheostat. So you see there is a cylinder, and over this cylinder, wire is wound. So electric current enters from A, goes on these loops, and passes through these slides and leaves from B. When you move this slide backward and forward, you are making a change in the length. So when you move this slide to the right, when you move it in here, length increases. When you move it backward, length decreases. Remember, if length increases and decreases, resistance also increases and decreases, correct? Do you remember this in the previous title we studied? So this is how a rheostat can change the resistance of a circuit. As there is a sliding contact, this is a sliding contact, and you can move it. A sliding contact is used to increase and decrease the resistance. When you move the sliding contact to the right, so when you take it in here, length of the conductor gets bigger. If length gets bigger, we know that resistance increases. When you move the sliding contact back, for example in here, this time length gets shorter. If length gets shorter, resistance decreases. As sliding contact changes its position, length of the wire changes, so does the resistance changes. And we know that as resistance changes, electric current of the circuit also changes. So by means of this rheostat, you can control the electric current of a circuit. So thus the electric current of the circuit can be controlled by the rheostat.
Teacher, what does it mean when it says without replacing with another resistance?
In this example, what we did, instead of 5 ohm resistor, we put another resistor, 10, correct?
Yes.
So this is replacing. And putting instead of one resistor, another resistor. You are going to take one resistor from the circuit and you will put another resistor. But by using rheostat, you don't need to replace it. Just you are going to move the slide backward and forward as you can change the resistance. This device is called variable resistor. As I explained, when you are moving the sliding contact, what you are changing?
Length.
If length changes, what happens to resistor?
It also changed directly with L.
Oh, we changed the resistance, correct? By using this rheostat. Did we replace with another resistor?
No.
So this is a good way, not? So you don't need to open the circuit, close the circuit again. Just by using this, by moving the slide back and forth, you can change the resistance of a circuit by using a rheostat. This rheostat is called variable resistor. Its structure is like this. Okay? Variable yani changeable.